Now, 2148 provides support for three types of embedded serial communication. So what are those three? So we have just studied when we studied the architecture. One is UART, Universal Asynchronous Receiver Transmitter, UART protocol. So it supports two UARTs, UART 0 and UART 1. It's an asynchronous communication. It provides another two serial protocols, which is of synchronous communication. One is I2C and SPI. So all the microcontrollers, most of the microcontrollers supports these three types of embedded serial protocols. So why I'm calling embedded? Because any motherboard you take it, the microcontroller or microprocessor talks to the other chips, ICs on the board, or talks to some of the devices located very near to that board through these protocols. So UART, I2C, SPI. So now let's focus on the I2C. So what is an I2C protocol? So we will study I2C with reference to first introduction, architecture, so the features, data transfer, rates, and protocol. Number one, I2C is being introduced to the market by the Philips Semiconductor. So I2C, the credit goes to the Philips. Now, this protocol is being supported to connect microcontrollers and the processor to the very nearby peripherals like RTC chip, E2PROM, ADC, other sensors. So I2C is used. It's an intra-board communication and a short distance. So you can connect one chip to the other chips like a sensors, EPROMs and RTC. Now, so let us understand hardware architecture. I2C architecture is supported by the two pins which are part of the bus. When I say I2C bus, always two wires are there. It's called two-wire protocol. So what is the first wire? The first wire is called SDA. So SDA means serial data. Because it's synchronous and it's a serial communication, the data is sent one bit at a time. Since it's a synchronous and whenever you send the data from one device to the another device, you require a clock along with that. So that is why the second pin is provided to support the clock called SCL, serial clock. So I2C bus has got two pins. One is data, one is a clock. And both these wires which connects the multiple devices has to be pulled high. You can see that there is a resistor is used. So the minimum requirement of I2C is what? The two pins which are used to connect multiple devices has to be pulled high to the 5 volts. This is a compulsory requirement. Now, I2C is a half duplex serial communication. That means that there's only one line is there which is used for both sending the data, serial data, and receiving the serial data. I2C is a master-device communication in the sense whenever communication establishes between two devices, one has to be the master, other has to be the slave. I2C supports multi-masters in the sense, so if you look at this bus, there's a one master 01, there's another master 02 is available. So that means that you can have many masters are there, but any one master can be used at a time. So we can use any one master at a time. So I2C supports multi-slaves. It's a multi-master, multi-slaves. So how many slaves can exist? In the normal mode, 7-bit address, there are 128 devices can exist in the total architecture. If you go for a, not the normal mode, 10-bit address mode, you can have a more than 1000 devices can exist in the system. So if this master has to communicate to this slave, so that means that this master uses the bus to talk to this slave. So using those three pins. So always the master is the one which generates the clock. So the data can come either from the slave to the master or master to the data, but the clock is always generated by the master. So if this is the clock line, clock is always output to the master, whereas data can be what? Both the direction, bidirectional, it can be bidirectional. So now we've understood that it's a multi-master, it's a multi-slave configuration. Now let's understand some of the features of this one. Number one, so it supports 128 devices in the normal mode. What is the speed at which I2C works? I2C works in a normal mode at 100 kilobits per second, but now there are modes which can be called as a fast mode plus, high speed mode, and ultra fast mode. So it supports up to 5 megahertz. So in general, people generally use them for 100 to 200 kilobits per second for using them. Now let's understand how does the I2C protocol works. I2C protocol is implemented in terms of messages. Let's say master is there and the master wants to communicate. So master wants to communicate to the slave. So how does the protocol works? Well, let's understand that now for a moment. So here is a master is available. Now there is a slave is on the other side. Any communication happen from the master to slave is through this message. So first, every message should be start with a start and should be end with a stop. This is the enclosed. The whole message is enclosed between the start and stop. Now, since many slaves are there, master should send address of the slave. Every slave, when you connect a device, they would have fixed. For example, so RTC chip in the market, they have assigned addresses. RTC will have a particular address called 68. For example, if you take an LCD, maybe 42, 48. Like every device, I2C device available in the market, they have got a fixed address. So you know that when you build a circuit, you will be knowing that I2C devices means what is that address you should note down. Now the master should generate after the start address of the slave. So all the slaves receives this address. Only one slave will have this address. So that will identify, and that slave should acknowledge the master saying that, so I have been there here in the architecture. I will be able to communicate to you. So that bit is called acknowledgement. So only one slave which has got this address will send an acknowledgement to the master saying that this address is mapped to me. Now, so once address is identified, a slave is identified, then master can send the data to the slave or receive the data from a slave. So how does the slave knows whether it is to communicate back to the master or receive it? So after the address, there is a one bit is indicated by the master called as read and write bit. If the bit is 1, let's say it's a read. The bit is 0, it's like a write. So the meaning is being conveyed in this bit. The slave reads this bit and ready for the communication. If it is writing from the master, then the master sends the data in 8 bits of data. So in I2C, every data frame is 8 bits. So all the data communicated from master slave, it communicates in terms of frame. So first frame is what? Address frame. Second is a data frame. So this data frame can be sent from the master to the slave or slave to the master. So if it is writing, so then slave will receive these 8 bits and send an acknowledgement to the master saying that I have received it. If by chance wants to read from the I2C sensor, so then this bit has to be write bit. Then master receives the 8 bits put by the slave, and then master sends an acknowledgement to the slave saying that I have accepted the 8 bits. So like this, multi bits or multiple 8 bits data frames can be communicated from the master to the slave and then terminated by a stop. So this is how the I2C protocol works. So this is about the features about the I2C. So we have understood. So I2C is from the Philips. It has got 2 lines, SD and SCL. Both should be pulled high. It's a multi-master, a multi-slave mode. 7-bit address is identified to all the slaves. So initiation of communication start from the master, and always master generates the clock. I2C protocol works at 100 to 200 kilohertz. So we don't have a program in the syllabus. So I'm not required to read the registers also. Only how does I2C protocol works. So now we'll go to the SPI. So now, how does the SPI works? Now, SPI is another serial protocol, synchronous serial protocol supported by the LPC2148. LPC2148 provides two I2C ports and two SPI ports are there. So SPI is a protocol proposed by the Motorola Corporation. I2C means Philips, SPI means is a Motorola, where SPI protocols are used whenever large data transfer has to happen at a higher frequency than the I2C. So, and the peripheral is located on the board. It's an intra-board communication. So then SPI is used. I2C is used when data is very small, 1 byte, 2 byte, you have to read from a sensor. People use I2C. When I want to send at least 100 bytes to the LCD display to display some picture on the LCD, then I require SPI. I want to read the block of data, kilobytes of data from SD card. I2C becomes very slow. So people use SPI protocol. So SPI protocol is used when a large data at a higher speed is required and it's an intra-board communication. SPI is being used. So SPI is used to interface LCD displays, flash memory chips, and SD cards. Now, what is the architecture, bus architecture of SPI? SPI communication happen using a 4 lines. In I2C, 2 lines were there. Here it's called a 4-wire communication. So what are the 4 wires? Why 4 wires are required? I2C is a multi-master, multi-slave, whereas SPI is what? One master, multiple slave. Only one master can exist and multiple slaves can exist. So in this, it's a full duplex. I2C is a half duplex. When I say full duplex, there are 2 pins are required to make the communication happens. So that means that master, if it wants to communicate to the slave, so it uses one of the line to send the data, like a transmit data in UART. So the name of this pin is called MOSI, master output slave input. So that means that data communicated from the master to slave go through this pin. Similarly, when the master wants to read the data from a slave, then one more separate pin is provided, master input slave output. That means that slave sends the data on this line, master receives it. So that's why it's called full duplex. Again, like an I2C, it is a master initiated transfer. That means that any transfer should happen, it should happen through master. A slave cannot initiate the data like an I2C. So master should start. So that is why the master generates a clock to the slave, and also it's synchronous. That is why clock is generated along with the data. So these are the 3 pins which are required for communication. So if I am not reading any data, only 2 pins is sufficient. Clock and the MOSI is sufficient. But if I'm reading also, then you require 3 pins are required. Now what is the 4th pin? It's called slave select. So that means that every slave master communicates, there's a one separate slave select line should be there. If there are 2 slaves are there, that means the 2 slave select line should be there. So this is one of the disadvantages of an SPI protocol. You can just look at here. So in this diagram, so you can see that. So I have 3 slaves are indicated here. So 3 slaves, slave 1, slave 2, slave 3. SEK is common for all the slaves. MOSI is common for all the slaves. MISO is common for all the slaves. Since these 3 lines are common for all the slaves, whenever master generates a data, the question comes, who has to receive it? There is no protocol called address concept in SPI. In I2C, address concept is there. First it generates an address and then communicates with the slave. Here there is no concept of an address. No protocol support for the address here. Then how does the slave know that this data is coming for me? That is why every slave has got chip select. Slave select line will be there, and separate one hardware line is required for every slave because it's not supported at the software level. So support is provided at the hardware level. So if the master wants to communicate to the slave 1, so what should I do? First, I have to make the slave select enable for this chip, disable the slave select for this chip. So usually it's an active low. So whichever the slave want to communicate, we have to make this line low. So it is being low and you have to maintain these 2 high. So then the chip understands that oh, the master has made this line low. So now the data coming is for me. So all the logics are enabled. Very simple hardware is being used in the SPI. It's nothing but shift register here. Here one shift register is there. Whatever the programmer wants to send on the SPI, just write into the shift register. So the SPI logic sends the data of the shift register output on the MOSI line along with the clock. Here another shift register is there. As the data comes here, the shift register converts serial into parallel out. Then programmer can read the data from the shift register. The simplest hardware implementation of any serial protocol is SPI, because it's nothing but one shift register. Only just write the shift register. One will convert parallel to serial, other will convert serial to the parallel. So if somebody asks, which is the hardware simplest implementation of I2C SPI UART? So SPI is the simplest support, and that is why it can run or it can transmit the data at very high frequencies. So frequencies up to 1 megahertz, and latest one, some mode supports up to 10 megahertz. So this is the hardware architecture of the SPI protocol. So you can just see that pushing the data from the master. The clock is generated automatically by the master. Let's say code S, just write into the shift register. The shift register sends the value of the code S in the form of data on the MOS line. Slave receives it. If the slave has to send it, the master generates the clock and the slave places the data. So this is how it is done here. So disadvantage is more lines is, because if you have 2 slaves, you require a 4 plus 1, 5 lines are required. So this is all about the SPI protocol, their hardware, and does it work. So there is no just writing to the shift register, and it can go up to 10 megahertz. The speed can go up to 10 megahertz.